we already know there are two different types of statistical methods. One are inferential methods and the other are descriptive methods. In this module, we'll be talking about something that form the basis for inferential methods. Descriptive methods are definitely used to describe our samples, but inferential methods are the one that help us to generalize our results for the population. Whereas the probability is a concept that plays a role as a bridge between the inferential methods and descriptive methods. Let's take a look at this picture where we have this larger population. From this larger population, we've drawn a smaller sample out of it, where we understand that this sample is the most representative part of our population. We always like to generalize our results of our sample to the population, but it's just not simply easy to do it using descriptive methods. For the generalization, we have to rely on inferential methods. But for inferential methods, they are based upon the lot of uncertainty and certainty. Probability provides us the help to discuss about this generalization of our sample results to the population with certain level of probability involved in this. Probability is needed for statistical tests and confidence intervals. You might have asked these questions sometimes, that what are the possible routes that I can take in going to school? Or should I bring my umbrella tomorrow? Is it going to rain tomorrow or not? Will I probably win in this game? How likely is it that I will be called to recite in our class? And similarly, we might have heard someone saying such type of statements, like a doctor says that a patient has a 50-50 chance of surviving a certain surgery, or a person has 95% certainty of curing after the treatment, or a nurse may say that 9 out of 10 person will miss a dose. When we quantify such terms like certain, probable, likely, or the chance, we are talking about the probability. Probability is a relative frequency in the population. But to talk about the probability, we definitely need to firstly get to know about the random experiment that leads to some events. And finally, there comes the probability. When we talk about probability, these random experiments are very important. An experiment is some activity with an observable outcome. Whereas a random experiment is such an experiment that's repeated number of times. And under the similar conditions, it still provides a different outcome. Such experiments are the random experiments. Few examples of random experiments are tossing of a fair coin, diagnosing a person for a specific disease, measure the body height of an individual, or rolling a die. When the blood type of a patient is determined, the sample size may be represented by S, which is the sample space. It is A, AB, B, or O. These are different blood groups. Here in the above example, our random experiment is a blood test. Our sample space is S, which is it's a collection of all possible events. And the outcome, when any possible value of a sample space, that is A is an event, AB is an outcome, B is an outcome, or O. These all different values are different outcomes. Moreover, when we talk about the random experiment, every random experiment have certain outcomes which are called the events. So when we define a sample space, it's a set of all possible results of a random experiment, whereas the events are the subsets of this sample space. For example, when we talk about diagnosis, a person could be sick or healthy. When we roll the dice, the outcome could be 1, 2, 3, 4, 5, and 6. These are all possible outcomes that could come out from the dice. And if we talk about the body height, it could be any value that's above 0. But when we talk about the events in a dice, 2, 4, and 6 are even numbers. So there could be an event A, which says that the numbers are even on a roll of a die. Or an event could be 1. In the body height, the event could be body height is greater than 180 centimeters. Or it could be the body height between 170 and 180 centimeters. Some events that always occur, like the sample space, are called the sure events. And the sure events are the ones that has 100% chances of occurrence, with the probability equals to 1. The other events which are impossible are called impossible events. Like in a roll of a die, if we talk about that our event is that outcome is 7, it's an impossible. Because on a die, the values could possibly be 1, 2, 3, 4, 5, and 6 at max. But the value will not be 7. So such an event that the outcome is 7 is an impossible event. And for impossible event, the probability is 0. Let's look at this Venn diagram, which is going to help us to define events in the future. The way we construct a Venn diagram is that we draw this big rectangle. This rectangle shows the sample space. Within the sample space, there are circles. These circles represents our events. A represents event A, and the purple one is the B. That's event B. Within an event A, there is a small a, which represents the outcome of an event A. And there is this joint area between event A and event B. This is the intersection of event A and event B. So events are of two types. There are simple events and there are composite events. If an event consists of exactly one outcome, it's called a simple event. But if an event consists of more than one outcomes, it is called a compound event or composite event. Like in this Venn diagram below, event A is a simple event and event B is a compound event. Because in event A, there's only one outcome, that's A. But in event B, there are two outcomes, B1 and B2. Hence, A is a simple event, whereas the B is a compound event. There are various other types of events, like mutually exclusive events, collectively exhaustive events, equally likely events, independent and dependent events.